In this video, I'm going to go over uniform and normal distributions. The focus mainly is going to be on normal probability distributions, but for uniform, we're just going to do one short questions. Uniform probability means when all the probabilities are the same. For example, if I say the distribution of rain during a week is uniform, it means the probability that will rain on Sunday is 1/7. Why 7? Because there are 7 days in a week. Monday 1/7, Tuesday 1/7, and so on and so forth. So we're going to do this example. High temperatures in a certain city for the month of August follow a uniform distribution over the interval 64 to 92. So from 64 to 92, the probability that the temperature will be any temperature between 64 and 92 is very much the same. How do we sketch this probability? This is what you do. You draw a horizontal line, a vertical line. The horizontal line will be for the temperatures and the vertical line will be for the probabilities. So I put 64 here, as you can see, and 92. Now how did I come up with the 1/28 here? You subtract 64 minus 92 minus 64 will give you 28, and since the probability, so there are 28 temperatures, and since the probability is the same for any temperature, so it will be 1/28. So you put 1/28 and you draw this horizontal line there and a vertical line here, and you get a rectangle. Now the question, what is the probability that a randomly selected August day has a high temperature that exceeds 69? So we want to know what would be the probability that the temperature will exceed 69, meaning from 69 and up. So what I did here, I drew a vertical line representing the black one representing 69, and I want to show you that what we're looking for. We're looking for this area right here. Remember, probability is an area, is a percent. So we need the area under the curve above 69. This is where 69 right here. Okay, how do we find this area? This is a rectangle. The area of a rectangle is length times width. Or if you want to think of it here, it's width times height. Now, what is the width of the rectangle? The width of the rectangle goes from this red dot all the way to 92. What's this distance here? You just subtract 69 from 92. That will be 28. Now, what is the height of the rectangle? The height of the rectangle is 1/28. So you just multiply 1/28 by the difference between 69 and 92. And I did the math right here, so let me show you. Probability of x greater than 69 equals the area of that rectangle whose width goes from 69 to 92 and whose height is 1/28. So that will be 92 minus 69 divided times 1/28, which is 23/28. If I go to my calculator, and 23 divided by 28 will give me, let's do it to 4 decimal places. I've been doing areas to 4 decimal places, so that will be 0.8214. Okay, that's the first part. The second part, find the high temperature which 90% of the August days exceeded. Okay, so we want the temperature where 90% of the temperatures are higher than. So this rectangle is 100%, the entire rectangle. This is the 90%. So we need to figure out the x value between the area shaded in red and area shaded in blue. This value here, that temperature. So the red area is only 10% and the blue one is 90%. The 10%, how did I come up with the 10%? 100% minus 90% is 10%. He gives us the area and he wants the x value. Well, the red rectangle, the area of the red rectangle is again the width times the height. What is the height of the rectangle? Is 1/28. What's the width? If I knew this number here where I'm pointing right now, I would just subtract it from 64 to get the width, but I don't know the number. That's what it's asking for. So I put x minus 64 times 1 over 28 equals 0.1. Multiply both sides by 28, guys, so you get x minus 64 equals 2.8. And then if you add 64 to both sides, you get x equals 68.8 degrees. So the number right here is 66.8 degrees. So that is everything that you need to know about uniform distributions. I'm going to go to the next exercise now. Finding z-scores. The mean IQ score of adults aged 20 to 29 years is 100 with a standard deviation of 15. Find the z-score of a person whose IQ score is 123. This is the formula. I will be providing you with the formula, but I think you should know it by heart by now. So how do we calculate the z-score? First of all, we put the x value. So let's put the x value right here, which is what? 123 minus the mean, it's 100, divided by the standard deviation, which is 15. 123 minus 100 is 23, divided by 15. Let's go to the calculator and do that. If you want to do this on the calculator in one shot, make sure to use parentheses first. 123 minus 100, and then close parentheses, divide by 15. That would be 1.53. For z-score, you always have to round it to 2 decimal places, so that will be 1.53 in our case. What is the z-score? Oh, I'm sorry, I put it in the wrong place here. Right here. 1.53. What is a z-score? A z-score will tell us how far is 123 from the mean by numbers of standard deviation. So 123 is 1.53 standard deviations above the mean, which is 100. It's very important that you use a parentheses if you're doing the z-score on the calculator. You want to do it in one shot, because if you don't put parentheses, what the calculator will do, it will divide 100 by 15 first, and then it will do 123 minus the quotient. So make sure to use parentheses. Or I would do, if I were you, subtract 100 from 123, I get 23, and then divide it by 15. Okay, let's go now to normal distributions. That's the backbone of chapter 7. Assume that the speed of vehicles along a stretch of I-95 has an approximate normal distribution with a mean of 71 and a standard deviation of 8 miles per hour. So these are the critical information, guys, here. So we have the mean equals 71 and the standard deviation equals 8. Okay, I'm going to write down the mean is 71 and the standard deviation is 8. It's very important that you write those two very important pieces of information. Approximately normal means the curve is bell-shaped. The distribution looks like a bell-shaped curve. Well, actually, this is going to be the case of all situations in the course from now on. The current speed limit is 65. What's the proportion of vehicles that is less than or equal, that has a speed less than or equal to a speed limit? When I say proportion, guys, it means a probability, it means area, it means percent. The reason why I'm using the word proportion, just in case if you see it, you know he's asking for probability. So we need the probability that probability of a vehicle has a speed limit less than this current speed limit, which is 65. So we need a probability of x less than 65. You write this down. You have two choices: to do this by hand using table 5, which will be provided to you, or you can use the calculator. So I'm doing it both ways. I'm going to do the table first, the standard normal table, and then I'll show you how to use the calculator. In order to use the table, you need to change 65 to a z-score. That's why I gave you this question on the z-score before, so you can get used to it. So to change 65 to a z-score, now you change the probabilities from x less than 65 to z less than whatever the z-score is. How do we do the z-score? It's x 65 minus the mean, which is 71, divided by 8. If you subtract 71 from 65 and divide by 8, you will get negative 0.75. So we need the probability of z less than negative 0.75. And let me show you how to use the table. Okay, here's how the table works. The ones digit and the first decimal you get in from the vertical line, and the second decimal digit you get in from the horizontal line. So the first whole number is 0, the first ones, the ones digit is 0, and the second one is 0.7, so I need the negative 0.7, which is right here. Now we need the 5 is right there. So with the mouse, I'm going to move horizontally on the line that has negative 0.7 until I see the 0.05 on top, and I see it is 0. As you notice, it is 0.2266, and that should be the answer. So I'm going to type it. This is how we use the calculator, not the calculator, the table. If they ask you to find what percent of the vehicles have a speed that is less than the speed limit, you change this one to a percent. If you want to change this one to a percent, it will be equal to what? Multiplied by 100, it will be 22.66%. So you can write it this way. Okay, using the calculator. Let's do this part now. That's the easy and a quick part. We need a probability of x less than 65. The function that you'll be using to find normal probability, it's called normal CDF. So let me show you how to access this function on the calculator. I'll clear here. So you go to second, and then variables, and it's number 2. Select number 2 and press enter. Now the calculator will ask for a lower bound, upper bound, mean, standard deviation, and then you paste it. Since we want the probability of x less than 65, how much less? As much as it can be. So the lower bound in this case will be whatever the calculator is displaying. This is a very, very big number, but with a negative sign. What I would suggest, if you don't like this number or you don't want to use it, I suggest for lower bound always. In the case of we're doing the probability of x less than a number, I tell my students to use negative, like, let's say 10,000 or a million. Upper bound. What is the upper bound? Can we exceed 65? No, it says probability of x less than 65, so this is your upper bound. Mean. What is the mean in the problem? It's 71. What's the standard deviation? It is 8. And paste, and then press enter, and here's the answer. As you can see, it's not different from what we did using the table, 0.2266. If it was different, it will be very slightly different in here. Okay, let's move on. Next question. What proportion of the vehicles will be going less than 50 miles per hour? Pretty much the same as in the previous part. So we need a probability of x less than 50. I need to change 50 to a z-score. That's very important. So that would be 50 minus 71 divided by 8. And if you guys do the math, it will be negative 2.63. Now let's figure out what is it going to be using the table. So as I said before, the negative 2 and 0.6, we get it from the vertical line. and the 0.03 we get it from the horizontal line. This is the 0.03 as you can see, guys, and this is negative 0.26. So let's move along the negative 0.26 until we are right under 0.03, and what's the answer? 0.0043. 0.0043. If I want to write this as a percent, guys, it will be 0.43%. This is a very low probability, and it does make sense. If the speed limit is let's say 65 or 7, you're not gonna see a lot of drivers driving at a speed of 50 miles per hour. In this case, we say this probability is unusual to happen, because anything unusual if the probability is less than 5%. Just keep that in mind. And anything that is 5% or more is called usual. Okay, using the TI-84. Let me just clear this one. Probability of X less than 50. It's a normal CDF, so let's go to second variables again. It's number 2, not number 1. We will not be using number 1 at all. Lower. You guys, you can make this assumption. Anytime you are doing probability of X less than a number, something, the lower is going to be this number, negative a million, negative 10 million, whatever you want. Just make it very large, but from the negative sign. Upper, okay, we're going to change that 1 to 50 now. The mean remains the same, the standard deviation remains the same. Paste, and press enter, and as you can see, nice match, which is 0.0043. Good. Let's go to part C now. Alright, that's part C. A vehicle on the highway stretch is selected at random. What's the probability that its speed is more than 75? So more than 75, this is how you write it down. You need to write this, probability of X more than 75 equals probability of Z greater than. I'm changing 75 to a Z-score. 75 minus 71 divided by 8, that will be 4 over 8, which is 0.50. Now, in order to use the table to find this answer, the table produces areas to the left of the Z-scores, but when I say probability of Z more than 0.5, I say we want to go to the right of 0.5. The table doesn't do that, but there is a relationship between the area to the left and area to the right. If you add them up, you should get 1. So in order to find the answer here, you do 1 minus probability of Z less than 0.5. For this one here that I selected, you can use the table, and then you can do 1 minus the answer. So let's see. 0.50. The 0.5 I get it from the vertical line, and the 0.00 I get it from the horizontal line. So we're right here, and this is the 0.5. So the answer is 0.6915. 0.6915. Okay, let's do the math on the calculator. So we go here, 1 minus 0.6915, enter, and that's your answer, 0.3085. Using the TI-84. Again, you have to go normal CDF, lower bound, upper bound, mean, and standard deviation. So probability of X greater, let me just fix this here, 70, what was it, 75. All right, we'll go second variables, normal CDF. Okay. Now, what's the lower? I said I want the probability of X more than 75. So 75 is the lowest value that we can begin with, so I'll put 75. What's the upper? There is no limit for the upper, so you can make it 1 million. Mean is 71, standard deviation is 8, and then scroll down, paste, and here's the answer. I'll write it down here, which is 0.30, almost perfect match with what we're doing using the table. Okay, D. A vehicle on the same highway stretch is selected at random. What's the probability its speed is between 65 and 78? So here, we need the probability of x between 65 and 78. Okay. Now, we need to change x to a z value, so I need to change 65 to a z-score and 78 to a z-score. Here's how you change 65. It's 65 minus 71 divided by 8, and for 78, 78 minus 71 divided by 8. You guys, you do the arithmetic here. It's going to be a probability of z between negative 0.75 equals and 0.88. There's a formula here. Probability of z between two values a and b. It's a probability of z less than b minus probability of z less than a. Meaning, every time you want to use the table, if you have z between two values, you find the area to the left of one value, the area to the left of the other value, and then you subtract. So we simply use table 4 or table 5, which is the standard normal table. So let's do that. 0.88. Okay, I got the table here for 0.88. So the 0.8 we get it here, and the other 8 we're gonna get it. I did not provide this. Let me just put the other side of the table. Let me make it visible. Okay, I put back the other side of the table, the horizontal row that has the 100th digit of the z-score. So we need 0.88. So guys, if this is 0.88, watch the arrow, and then I'm gonna stop when I'm right under the other 8, which is 0.88. So that's 0.8106. Minus. You wonder, I didn't put the portion of the table where we can do z, probability of z less than negative 0.75. Well, we did this earlier, and that's the answer. Probability of x less than z less than negative 0.75. We got it at 0.2266. Okay, let's do the math on the calculator. So 0.8106 minus 0.2266. It's 0.584. All right, let's do the calculator. The calculator is much simpler for this one when x is between two values. Probability of x between 65 and 78. You go to normal CDF, provide lower bound, upper bound, mean, and standard deviation. Okay. Let me just rewrite this. Parentheses, that's how you write it down. 65 less than x less than 78. All right. So let me clear the screen here. Go to second, variables, normal CDF. Okay. Well, he's telling us he wants the probability of x between 65 and 78. So he's given us the lower bound and the upper bound. The lower bound is the 65. Enter. The upper bound is the 78. We don't need to worry about a million or negative 10 million here. A mean is 71. Standard deviation is 8. Paste it and then press enter, and here's the answer. 0.5826. Okay, let's go move to the next question. A new speed limit will be initiated such that approximately 10% of the vehicles will be over the speed limit. What is the new speed limit based on this criterion? Okay, in this problem, He's given us the probability and he wants the x value. So we're going backwards here. What is the probability here? 10%. Remember, probability is an area under the curve. Now the question is this 10% gonna be to the right of the curve where I shaded, or to the left? Why didn't I shade to the left? Because it's 10% here. Well, over the speed limit means you'll be going over the average, which is right here. So definitely you're gonna be on the right because it's gonna be a high number. This is a top 10%. So this is the area, this is the 10%. Our question, guys, is to find the x value right here. Now to do this by hand, first of all, I cannot find the x value right away. I have to find the z-score, and then from the z-score I can convert this to an x value. So this area is 10%. What is the area to the left in here? The area to the left is 90%. Now why I'm asking for the area to the left? Because your table only works with areas to the left. So we know this is 10%. We need 90% area to the left. What I'm going to do here, this is the table. I'm going to go inside the table and see where would be a value closest to 90%, which is 0.90. Okay, let's see. 0.90, I would say this is the closest right here. Can you look at, see it? Let me just see, show you here. 0.8997. See, the mouse is pointing to this one. That's the closest to 90%. So what would be the z-score here? It's 1.28. So is 1.28. I'm going to type this value. Now, we have a formula that says z equals x minus mean divided by standard deviation. The x we don't know. The z we already found using the table, which is 1.28. The mean we know it's 71, and standard deviation is 8. If you rewrite this formula, you'll have a new formula for x. X will be the standard deviation times the z-score and then plus the mean. So that would be what? 1.28 times standard deviation is 8 plus what? 71 equals. Let's do the math on the calculator. So we have 1.28 times 8 plus 71, enter. So that would be 81.24 miles per hour. Okay, using the calculator. Let me show you how to use the calculator. If you are given the probability, how to find the x value, not even the z-score. It will give you the x value right away. That's the beauty of this. So I'm going to clear the screen. I'm going to go to second variables. There's another function in this chapter you'll be using, just two functions. It's the number 3. So normal CDF to find the probabilities, and inverse normal to find what? X values. Okay. It asks you for 3 arguments: the area, the mean, and the standard deviation. The area, guys, it has to be the area to the left. So if I give you the area to the right, in order to use the calculator, you need to subtract this from 100%. Otherwise, you will get a wrong answer. Since we were given the area to the right to be 10%, the area to the left is what? 90%. So I'm just going to put 0.90. Change it to a decimal. Mean is what? 71. Standard deviation is 8, and press enter, and here you go. Perfect match. 81 point, almost perfect match. Which one is more accurate? The calculator is more accurate because we round the z-scores, but on the calculator we don't. Okay, this is very much it. That summarizes everything about how to find normal probabilities. I'm going to do a couple more exercises using the inverse normal function in here. Okay. Number 4. A group of students at a school takes a history test. The distribution is normal with a mean of 25 and a standard deviation of 4. So make sure, guys, to write that mu is 25 and sigma, which is a standard deviation, is 4. Everyone who scored in the top 30% of the distribution gets a certificate. What is the lowest score that someone can get and still get the certificate? So top 30%. I shaded that in black, so that's the top 30%. Well, and top means to the right. Now, if the area shaded in black is 30%, the area shaded in purple is what? 70%, and that's what we need in order to use the table, because we always need the area to the left. I need the x value. As I told you, if you're doing it by hand, you cannot find the x value right away. You would have to find the z-score and then convert it to an x value. So what would be the z-score here? 70%, we need 0.7. Okay, let's look inside the table. I would say this one, the 0.6985, guys, is closest to 0.7. So what is the z-score that corresponds to it? It's 0.52. Okay, 0.52 right here, as you can see. Now, let's find the x. As I told you in the previous part of question 3, x will be the z-score times the standard deviation plus the mean. Okay, let's do it on the calculator. So that will be 0.52 times 4 plus what? 25. Enter. 27.08. So if a student scores 27 and a little bit more, they will be in the top 30%. Using the TI-84. Clear. Second, and variables, it's number 3 now, inverse normal. We agree that the area to the left in this situation is 0.7, so I'm going to put 0.7 here. Enter. Mean is what? 25. Standard deviation is what? 4. So I'm going to put 4. Paste. And here you go. 27.08. 0.0197, if you want to round it, would be 27.1. Slightly different from using the table. Okay. Next part. The top 5% of the scores get to compete in a statewide history context. What's the lowest score someone can get and still go on to compete with the rest of the state? Okay. So top 5%, this is the top 5%. As you can see, I pre-prepared this so the video does not last very long. So this is the 5%. I need this value right here that would place, a students at the top 5%. Well, if the top 5% is an area to the right, so what would be the area to the left is 95%, because 5% plus 95% is 100%. Change 95% to a decimal will be 0.95. Let's look up the 0.95. 0.95, okay, the closest I can see is 0.9495. It's 5 marks away below. But look at this one, it's also 5 above. So which one do I use? I'm going to use both. I'm going to take the average of both. So you do 1.64 plus 1.65 and divide by 2. So I'll write it down here. 1.64 plus 1.65, and then divide this by 2. It will give you 1.645. I think that's the best answer. So x will be 1.645 times the standard deviation 4 plus the mean, which is 25, and let's see what the answer on the calculator is. Plus 25, 31.58. Using the TI-84. Clear. Let's go to second, distribute, inverse normal. Okay, area here is 0.95, so I'm going to change it to 0.95. Remember, it's area to the left always. Mean is 25, yes. Enter. Sigma is 4. Paste. And watch, guys. Almost perfect match. 31.58 actually. And that's it for this chapter. Let me know if any question. That should cover everything you need to know in this chapter.